What's up, guys? My name is Neil, and today we're going to be going over Emscripten. Um, this is something that I've been dabbling with for quite a while, but I've always kind of struggled with it, and I thought I'd make this video to kind of just help folks out there who are curious about it, but really don't know where to start. And especially those folks that are coming from, a web development background. So let's get started. A little bit about me, as I said, I actually do Angular development, and I work in .NET and C#. So, I'm mostly a full stack web developer. But what really got me interested in Emscripten was, really just WebAssembly in general, how popular it's been getting, and just some of the amazing demos that I've seen on the internet. Ports that people have done, games, game engines, and really just it got me so curious about it. But every time I've tried getting into it, it just seemed like a completely different world. So I just kind of wanted to show you guys, how to get up and running with Emscripten, some of the pain points that I went through that hopefully you guys won't have to go through, and really just see what this whole world is about. Because when I say world, I really mean that literally that, if you're coming from, web development, HTML, JavaScript, CSS, and then you get into things like, C++ and Makefiles, and even Linux, because for me, I come from a Windows world. All these things were just such a struggle for me. I'm used to things like, NPM and Node Package Manager, and, getting into things like Makefiles was really a struggle. But one thing I will tell you, though, once I figured it out, it was hugely rewarding, and it was such a fascinating topic. So I think the best way to go through it today is we're going to actually do a port of a popular library out there on GitHub called Libxls. So, and I chose this because I wanted to pick something that was, kind of useful, but also interesting in terms of it's not something you would think of normally when you think of like, being able to do with just web and JavaScript. So this is a library that allows you to parse XLS files, so normally you would do that on the back end, but that's the beauty of Emscripten and WebAssembly is, basically any library that was written in, low-level languages or C++, you could basically bring that power to the web. And that's really at the heart of where I see Emscripten and this technology for web developers. I don't see it replacing JavaScript, but I do see it as really another tool, in your shed, and a very powerful one, because not everything is appropriate for JavaScript. There's a lot of things that you can do, that you do better on the back end, but there's kind of that little gray area where, because we're pushing more and more to the client side, you'd be amazed at what you could actually do now on the client side with just a web browser, that you don't even need to have a server. And I think that's where Emscripten really, has a great usefulness. So first off, why WebAssembly? So, we've been hearing this buzzword. If you're in the web development world, you've definitely been hearing about this, and you might be thinking, like, how do I get started with this thing? So I think one of the most important pieces, or most important reasons to use WebAssembly is the reuse of old existing code. You think, modern browsers and HTML and JavaScript, those have been around for quite a while, but something like C++, I mean, that's been all around probably longer than I've been alive. I'm going to say, I'm going to go out on a limb, it's probably at least 30, 40 years. So there is a huge amount of, code out there, existing code on GitHub, almost anything you could think of, like I need to be able to do this, chances are somebody's written that, in some low-level language, probably, especially if you're doing something, again, like parsing an XLS file. there's probably some C++ library that does that. So the ability to just take that code and literally just, compile it down to WebAssembly, and then just being able to use that, again, I think is extremely powerful. And from a web development standpoint, you think about everything being modular. In a way, it's almost like just another library. It's another JavaScript file, because you don't really even care how it works. It's like a black box. You might use, let's say jQuery or React, or sometimes you just use a library that just prints, like a nice grid on the screen. Sometimes you don't care about how it works. You just, you want it to work. And that's really where I see WebAssembly becoming more and more popular, is kind of like these little mini tasks on the web. So I'll also mention, that's I think the most important thing, but I'll mention these others as well. So the ability to use different languages, so if you're coming from, a web development standpoint and you're very comfortable with JavaScript, maybe this isn't as important to you, but I thought I'd mention it anyway. There's C++ developers out there, and maybe they're coming from the other angle. They're like, how do I get into web development? So to them, that's also a very powerful thing. They can just use the language that they like and compile it down to JavaScript. There's also a very popular language called Rust out there, which is, I don't really understand it so well. I think it's obviously lower level than something like a JavaScript, so maybe it kind of hits that sweet spot. But it's probably a little bit more of a modern version of that lower level language. So those are kind of like, that's another reason you would use it. Another thing is it runs faster than JavaScript in most cases. So really the way it works is on a low level, it's actually is able to skip a lot of the different checks that you would do with regular JavaScript. JavaScript's extremely powerful, but it's also known as a very high level language. And what that means is that you can do a lot of stuff with, really very little code. And there's all kinds of checks and safeguards in place to protect your code. Things like types. You can very easily in JavaScript, take a string and then just turn it into a number. That's totally allowed in JavaScript. But the thing is that does come at a cost, in terms of performance. So, you get all that great functionality, but under the hood, it's got to do type checking on that. So, think about like, what if you could just skip all those steps, all that type checking steps? Well, that's kind of the heart of the idea of WebAssembly. It's kind of a raw format, but it's designed for the web to run. You're never going to write WebAssembly, from scratch. You're going to write in different languages and it compiles down to it. But because it's able to skip a lot of those kind of checks that you would have with regular JavaScript, it runs much, much faster in a lot of cases. And then one more I'll just mention on here, just because I think it's so cool, is game development. You think back, 10, 15 years, there's been such, kind of shifts in game development, and even game development on the web. You started with things like Flash, and nobody really uses that anymore. But now, the things you see on the web, I think it's almost like, what you had on consoles, maybe like, 5, 10 years ago. But I mean, it's pretty powerful. Our computers are pretty powerful, and the browsers, what they can do, and just, like their capabilities have just gone through the roof, So, so this is another big play for WebAssembly. Most games, if you guys know, is, in the industry, they're mostly written in C++. So this is another, one of those examples where you can kind of take an existing code base without changing too much and just get it onto the web. So I think that's just something I also wanted to mention. A couple examples. So, I mean, definitely take a look. I posted a link here on this slides, but they've ported things like Quake 3. DOSBox, SQLite. So these are all things, these are all like desktop applications, you know, but because of the beauty of Emscripten and WebAssembly, they were able to port it very easily. You've also got things like the Unity game engine and Unreal game engine. So these are, you know, really popular in the game industry. So they have added the web, HTML, is one of their targets, and the way they actually accomplish this is using this this WebAssembly technology and also emulators. So I'm going to post this link in the description below. Definitely check it out. There's some amazing demos that people have done, and it shows you the power of, you know, what this thing can do. So what is Emscripten? So basically it's an LLVM to WebAssembly compiler. So what does that mean? So LLVM, this is a technology that has become popular, I would say probably in the last, you know, 5-10 years in the world of compilers. So, you know, taking your code and turning that into something that, you know, the machine can read. So what LLVM is, it's kind of like a middle step between the code and the machine, where instead of going straight to machine code, there's this intermediate step where it becomes not quite machine code, but something that basically, you know, can be optimized very easily, and really you can just write that optimization one time, you know, as opposed to how they used to write compilers where everybody wrote their own compiler, and it always went from, you know, the source to the destination, and everybody basically had to reinvent the wheel. This was kind of like a game changer. So, and this was really the key to Emscripten, because of this, instead of being, you know, going straight from JavaScript or straight from C++, let's say, to WebAssembly, they didn't have to do that. They could just go from this LLVM step to WebAssembly, which is a much shorter hop. And that's basically what allows you to take any language that compiles down to this LLVM code. You know, theoretically, any language that can do that could be ported to WebAssembly. So it's not even just C++ and Rust, like I mentioned. I mean, and I'm sure there's going to be more in the future, but that's what that is. So Emscripten is it's a full suite of tools, and it's got this compiler component. But the main way that you're going to be utilizing it is using this command line interface. So there's the emcc command, emsdk, and basically how these commands work is that we're going to be passing in, you know, all kinds of parameters to these tools, and that's what's going to tell them how to take our code and then process it and then turn it into this this WebAssembly. So now let's take a look at actually going through and porting the code. Okay, guys, so the first thing that we're going to want to do is open up VS Code. I'm actually running VS Code in the browser. This is something called GitHub Code Spaces. Totally off topic for this video, but something really cool to check out. Basically, you can run your code in the web. And I'm basically just using it so that I can have, you know, a clean workspace to start from. So I didn't install anything yet on this image, but basically all you guys would need to use is just VS Code to get started. So the first thing we're going to do is we're going to install Emscripten. So basically, if you're going to also want to pull up the Emscripten website when you do this, because they have a lot of really good information. And so I'm just going to pull it up here. And basically, it's a very simple install. So the first thing you're going to do is you're going to clone the GitHub repo, which is this core repo where they have the SDK tool. So we're just going to go ahead and run that command. And the next thing that we'll do is we're going to run this install latest. So let's go ahead and cd into that directory. And we see that there are all the tools that we need. So the tool that we're running is called EMSDK install latest. So let's go ahead and run that. And while this is downloading, just something I'm going to mention. So this is a Linux environment. And I'm only mentioning that because I came from a Windows world, and so to me, I had to kind of get used to this a little bit. As far as I know, Emscripten does work on Windows as well, but most of the examples you're going to see out there, they're using Linux. So, and I believe it does work much better on Linux. And another reason also you're going to want to use this is for all the code that you download out there. So not even just the Emscripten tool, but even the code that you're going to be porting, beyond just, the library we're going to do today. Most of that code is designed around a Linux environment. And that was just something I realized as I started looking around GitHub as I got more into it. Everywhere I went, there was Makefiles and things like that. And basically all that stuff is really just designed around a Linux environment. So basically, long story short, you're going to want to get a Linux environment if you don't have it. Now, if you're on Windows, there is a technology called WSL, which stands for Windows Subsystem for Linux. And basically what it does is if you want to stay on Windows, you can kind of have the best of both worlds. I use it for basically all the Emscripten development that I do. So, and it works really, really well. It's great. So I do everything on Windows, but because I installed this WSL tool, I can basically, just have all my files in Windows, but whenever I need to have this, sort of Linux shell and a Linux environment, and it uses virtualization under the hood, but you're getting, the real Linux, even though you're on Windows. It's not. It is actually like a Linux VM, so they just kind of like hide the details, but it just works really seamlessly. So I definitely encourage you guys to get that if you're on Windows. If not, yeah, you are going to have to get a Linux environment. So, and another thing I'll actually mention about that as well, actually, let's actually run the next command while that's going. So yeah, there's only one other command in here, so it's just this activate command. So the first command installed, the tool, and then the second one activated it as the one that it's going to be using. So basically, you can have more than one version of Emscripten, and it actually comes in handy because some code out there works. Maybe was designed for an older version of Emscripten, so they give you the option to basically use an older version if, like, let's say the newer version, broke some functionality that you needed. I'm just going to be using the latest here. So, so once we install this, first thing you can do, sorry, there's one other command. So this installs it, but it's not in your path yet. So if you try to type emcc, you're going to see that doesn't work yet. So there's one more script you run, which is called emsdk _env-sh. And this has added now those Emscripten tools to my path, which means now I can type emcc and it says there's no input files, but now the tool works. If I write emcc -- version, I see that I'm on the latest version of Emscripten, which as of the time of this video is version 2.0.11. This is a script that you're going to basically run every single time that you log into your environment. Now, you could add it to your path permanently. I chose to basically just run it each time. Either way works, but this way they give you kind of the flexibility so that if you don't want it in your path permanently, you don't have to have it there, and you would just run this script, which is source emsdk env. Source means basically just add these paths to this process, to this Linux process that I'm in, but that's what that does. Another thing I'm going to mention, so while we're on the topic of Linux, there are going to be some tools that you're going to need to install. So this image that I'm using, even though it's the default image in GitHub code spaces, they already installed a bunch of stuff for me. So like, we're going to see later, we're going to need a tool called Make. And if I type Make, you see that it knows what this is. But you guys might have, a fresh Linux environment which doesn't have anything installed in it. So the only reason I'm mentioning this is for those of you who maybe aren't as familiar with Linux, you're going to run into issues where it's like, okay, I don't have this tool, or I don't know what Make is, or I don't know what Git is. And Linux actually provides a really easy way to install things, and it's basically the apt get install tool. So it's kind of like their own, app store, if you will, and it's a way to get, applications installed in Linux from a command line. You would just use that. So if you guys ever run into something where you type a tool like Make and it says, oh, I don't know what that is, the easiest thing is just go and you just Google, how do I install Make, and they're going to give you some command that usually starts with apt-get install. So just something to keep in mind. It was definitely something I had to learn, and it was something that was really useful. Once I got the hang of it, actually, I liked it a lot. It's really easy. You just type a command and then boom, you have that package. But yeah, so now we have this EMCC tool. So the next thing we're going to do is we're going to actually we're going to download the library which we're going to be porting to WebAssembly. So that's what this tool is. This is something I found this just on GitHub. It's called Libxls. It seems like it seemed like a cool example to use. It's written in C. So another thing to mention, C and C++ are different things. So C++ has more features than C. Normally, you can tell the difference between the two is from the file extension. So if we just go into source here, you see everything is a .c, and C is actually a little, it's going to be simpler. I actually like it a little bit better in a way, from a porting standpoint, because the code is a little bit simpler than if you were in C++, where you had things like classes and a lot of advanced features. It just makes things a little easier, especially for folks who aren't coming from a C background. So if we just take a look at one of these guys, so obviously there's a lot going on in here. And if you've never seen C or C++ before, you're definitely going to want to brush up on it at least a little bit. You don't have to be an expert in it in terms of the purposes of WebAssembly and from a web development standpoint. But if you're planning on using Emscripten, to do this kind of stuff, going out there and porting libraries to WebAssembly using the tool, you got to at least know enough to get by. And I would say that's probably that was the path that I took. Was when I first saw it, I kind of struggled with it, but the more I work with it, it just made more sense, and it's really not too bad. I'll say that, but there are obviously going to be differences if you're coming from a language like like JavaScript. One of the biggest differences I would say is the ability to manage memory, or how memory works. That's really the big difference, in terms of the control flow and all that. JavaScript, I wouldn't say is too much different than this, but the memory aspect is probably the one big difference between the two languages. So yeah, so we're going to go ahead and we're going to clone this repository. So let's just go back to our workspace here, and I'm just going to do a git clone like that. And now we should have all that code right here in our repository. Now, whenever you're kind of getting up and running with one of these kind of like porting tasks, first thing that you're going to want to do is definitely take a look at the README, if there is one. But these guys did obviously a very good job of documenting this stuff and just going through and explaining what you have to do. And again, going back to this whole theme of Linux, so if first step you're going to see in here is that they're telling you the installation. You're going to have to run configure and make, and then make install. So what I will say about this, and in this particular case, we're not actually going to be using the the configure tool. Basically what that does is it auto generates the the Makefile for you. And what I want to do is I want to actually show you guys how to make a Makefile from scratch. Now, Emscripten does have integration to all these tools. They have the ability to basically take an existing Makefile and pretty much, just turn it into an Emscripten Makefile. That's all. They all have that pretty much out of the box, and for the most part, it works pretty well. But and in general, just in programming, I find that the best way to kind of learn something is to really understand what's going on behind the covers, and then sometimes when you use the tool, just out of the box, it's just a little bit too much magic. And then, when something goes wrong, you just don't even know what to do or how to fix that. So, but that's basically what these tools do. So we're going to go ahead and we're just going to generate our own Makefile. So we're just going to create a new file here called Makefile. And really all these tools do when it really comes down to it is it's just a bunch of instructions to compile all of your C or C++ code. That's all it is. It's just a build system. And so there's really, and in terms of C++, one of the things I really like about it is that once you understand kind of how C and C++ compile, they basically kind of look at each file as its own unit. They actually call it translation units. But basically, you can go ahead and compile a single file into what's known as an object file. And it actually doesn't even need to have any dependencies. That all comes down into the later on in the linker phase, but I don't want to get too deep into the rabbit hole. But basically, all we're going to be doing with this Makefile is just telling, the computer a bunch of instructions to say, here's how I want to, compile my code. So let's go ahead and do that. And so normally I start with kind of like this little template that I have. And this was something that I've built out on my own, but it's worked for me. It works pretty well for me. Let me see if I could zoom this in. Zoom in. I don't know if I could zoom in the whole thing because I'm actually in the browser. But so basically, let's just take it from the top. So this first instruction here is just going to tell it to not use its own built-in compilers. We want to just tell it exactly what to use. And all this is basically a series of what they call a dependence tree, right? So it's basically saying to create this all task. The thing on the left is what's known as the target, and then the thing on the right is what's known as the dependency. So we're basically generating the XLS tool. And to create this XLS tool, it has to go down this tree and say, okay, how do I make this thing? So then you go down to this line. Well, to make this thing, I'm going to need this files, right? And files, all files is, it's just a variable. Basically, the reason I like this template is because it's pretty generic in the sense that normally you would go out and list out like, I want to, compile this file and this file and this file. And like I mentioned, you have to do that in C and C++. You have to say, here's a list of files that I first want to compile on their own, and then we're going to stitch them all together and link them together in that linker phase. But in this case, we're basically just saying, just compile everything. Anytime, you see a C file, just go ahead and compile that thing because we're going to need all these files. So that's where this wildcard comes in. So basically, all this is saying is that go out into the source directory, which is where we have all of our C files, and just compile every single one, right? And to do that compilation, we're using the GCC tool. So if you don't have GCC, you're going to want to install that. Type GCC. So we see that GCC is installed. If it's not installed, you're going to want to install it using the apt-get tool, like I mentioned before. But the way that I usually go about doing these kind of porting tasks is first I like to compile it down to native code, because then I can actually see, okay, does this thing actually even work, before I even go down the whole WebAssembly route. I just want to just see, can I even compile it just in native code? And that's where this GCC tool comes in. It stands for the I think it's the GNU C compiler, but that's what most folks actually use, I think, on Linux, to do to compile this. So so basically, yeah, it just says run this GCC, and the -O this is actually in the linker phase. So as we go up this tree, we're getting closer and closer to our final executable. So actually, we're going to go down to this one here. So this is where it actually compiles each individual file. So -C means compile, and it's going to basically spit out an object file for each one. There's also another task in here called clean. So this is good for if you just want to like delete all the object files and just kind of like reset your environment. It's a good way to just go ahead and just kind of like have one of these clean tasks, and you'll see this in a lot of Makefiles as well. So yeah, and I'll have the source code for all this stuff. I'm going to post a GitHub with this in the description below, so you guys can get this template as well. So let's go ahead and run this tool. So to run it, all you have to do is run make. It's just one word, and it's going to find a Makefile within that directory. So let's go ahead and do that. So the first thing we see here is that we have an error. So and this is pretty typical. I mean, it's pretty rare where you're going to go out here to one of these like C or C++ projects, and when you start one of these like WebAssembly porting jobs, and everything works from the get-go. So most of the work is going to be basically getting the thing to compile, which is what I found. And in this case, I've actually done this before, so I know what this error is. It's looking for this config.h file. The reason it can't find that is because we made our own Makefile. We didn't go through configure. So so basically all we're going to do is we're just going to comment that out. It actually really doesn't use that for much. So we'll go into the XLS tool, and we're just going to comment that out. Okay, and so basically all these are, and just if I didn't mention it before, these are header files. So sometimes you're going to want to find, where these are. They may not be in the same place as your C files, a lot of times they are, but if they're not, sometimes you actually have to tell the tool, where these are, and you do that with the -I command. But in this case, as we see here, these .h files, it's showing an exact path to those, so we actually don't even need to do that. But if it didn't have this exact path, you would need to use that -I command line. These other ones are mostly system libraries. So that's one distinction you're going to see, is that when it has these quotes, it means something within the directory that I'm in or relative to. If it's one of these, it's basically saying go out on my machine and find it in one of like the system directories where the compiler knows to look for these things. So let's go ahead and run the make tool, and again, we're going to see that there's another one of these references to config.h. I'm just going to go ahead and comment all of those out throughout the project. So we're just going to go into each one where it finds it here and do it like so. And that should be the last one. And let's go ahead and run that again. So now we get a different error. And again, you're going to see this kind of pattern is, as you get these different errors, you're just getting closer and closer to getting the thing to compile. So in this case, it's looking for something that's called package version. Let's go ahead and find that. And it's complaining that this is an unidentified parameter. Now this is probably gets populated by the configure tool, which we didn't use because we used basically our own Makefile. So I'm just going to type in 1.0 in here for the version, and finally we do get it to build. So if we could just take a look quickly down below, you'll notice what it did was it first compiled every C file to a .o file, and then finally it took all of those .o files and it spit out this final thing, which is the XLS tool. So that is an important concept to understand in C and C++, and as so far as you're using Emscripten to port these things, is that how it does this compiling. Now these .o files, you can kind of think of them as, as the compiled versions of just that file. For the, if you've come in from, like, let's say, the .NET world, they're kind of like the DLLs, if you will, of each file. But by themselves, they don't really do much, unless you're using them as like separate libraries. They really, have value once they all come together to form this last tool. So we have, so that's what this final phase does in the Makefile. So just so you guys understand, and we could comment out, any one of these phases to just, let's say, have O files, or if we wanted to just, have just the final file. It's good to understand what that breakout is. So now that we have this this final version, so we have this XLS tool, we can just run it from the command line just by basically typing ./XLS tool, and we hit enter, and sure enough, we do get the output option. So that means it looks like we compiled it successfully. And so basically, you see what this tool does is you can, tell it the name of an Excel file, and it's going to tell you, the values that are in all the different cells, and they have these different options as well. Basically, what I'm going to do is I'm just going to, test this thing out. So I'm just going to copy in this little sample Excel file that I have here called book1.xls. And this is just a very, basic Excel sheet. There's like really not much going on in here. Just, 2 columns of data. So let's just go ahead. Now that it's in the path, we're going to run the same tool, but this time we're going to pass in as an argument the name of that file. And as you can see here, it was able to parse it out, and it spit out all of these values. So yeah, so I mean, that's basically, building the native version. So now, how do we go from this to using Emscripten? Well, that's the beauty of Emscripten, is once you have this kind of like native build going on, it's almost no work at all to get it to work in Emscripten. It's pretty amazing, in fact. And obviously with more advanced projects, there may be some changes you make. If you get into like things like, let's say, graphics or game development, there are some differences. How like frames are calculated and delayed and things like that, run asynchronously and so on. We're not going to get into graphics at all today. I might do that in a future video. I just wanted to keep this simple today. But for our purposes, basically all you have to do is replace this GCC command with EMCC. And so EMCC is going to come in as a replacement for the GCC compiler. And again, the beauty of it is it basically takes the same parameters and the same structure as GCC, and for good reason, because the whole point of the thing is that you can take your existing code and basically, again, with very little changes, compile it down to WebAssembly. Another thing I'm just going to change in here, just to so the thing that we're producing, you want to actually tell this to produce an HTML file. So, and I'm going to show you, in a moment what the differences are. There are different options you have, but basically what we want is we want to be able to run it. We want to see what it looks like and try to run it in the browser. So the first thing that we're going to try to do is just get it to compile to an HTML file. So I'm just going to run a make clean. This is a good practice to do as you do these things. If you just compile the native version, you don't want to get confused with the native version of the object files with the WebAssembly version. So I usually do a make clean after doing a native build. So, and now let's just go ahead and run make again. And there we go. So yeah, no errors. And as you can see, it looked like pretty much the same output as when we ran make with GCC. I mean, the only difference again was just that first tool. It's just using EMCC instead of GCC, and it basically all just ran through exactly as we wanted. So let's go ahead and take a look at this HTML. One thing I will mention, actually, if you're using VS Code, I'm going to be using this live server extension. I highly recommend it. You're also going to want to install the C++ extension as well, which is what gives you all that, syntax highlighting and IntelliSense and all that stuff. So, but we're using the live server in this case, so because we want to actually just run this in a little web browser. And so our server is up and running. And because we're in GitHub code spaces, we just have to forward that port. And let's just view that. So yeah, all really live server does is it just gives you a built-in web server. So it's pretty handy. So let's just go into our Libxls folder, and we're going to take a look at the HTML file that was generated. So this is the built-in Emscripten HTML file. So as you can see, it's basically shows you, there's a canvas up here. There's no graphics in our case, but it also has a place for, for output, if the app prints anything. And then it also prints errors down here. So in this case, it actually thinks there's errors, but this isn't actually even an error. As you can see, this is the exact output that we got when we ran the native tool. So that's how we know that this thing is working. So as you can see, it's taking that what was that native app, and there's those command line options that we had in the native version. Now, in order to actually test this thing, you're going to need a file, right? And we don't have, because we're on the web, that's one of the things that's going to be a little bit different than when you do the native version. So kind of just hold that thought for a second. But while I'm here, I do want to highlight a couple of things. We have this module object, and this is very important because this is basically, the representation of our app. And there's a lot of functions on this thing. We're not going to get into all of them, but this is how you're going to be interfacing with your WebAssembly object from the outside world, from to the JavaScript world. And let's just go ahead. And so the way we actually run the app, and actually I don't think I can run this yet because we haven't exposed any methods yet, but basically we see that it is working. So what I'm going to do actually at this point is I'm going to actually use my own HTML file. I did want to show you guys that built-in Emscripten web file, just so you guys see what that looks like. And it's super handy just to quickly see what's going on. But in practice, you're not going to use this on a production site or even probably your own site. You're going to want to use your own your own HTML. But it's good to kind of just take a look at this thing and see what's going on. Basically, all it really does is it loads up this JavaScript file that comes hand in hand with it. And that's really the important one. That's what you're going to want to take with you. That along with this WASM file. So these two files are essentially your app that got compiled. And the HTML file is really just a way of viewing that and quickly just testing it and seeing what's going on. So I'm going to go ahead and just copy over just like a very basic HTML file. Oops, let's just put it in here. And let me just actually not do it from there. Copy these in like so. Okay. And I'm going to show you what's in these HTML files. I've kept them very simple purposely because I want to keep this simple, just so it's easier to understand. And so basically all that we have in here is just a basically kind of like hello world index file, and it's calling out to this script file, which again, there's not much going on in here either. I'll show you this in a second. It's just basic little JavaScript file that just, loads up and, just shows some text. I'm using a couple of little, libraries here just to style it up a little bit, jQuery and Bootstrap, but essentially there's really nothing going on here yet in terms of, Emscripten or anything like that. That's what I want to now add into here. So the first thing that you're going to want to do is you're going to want to include that JavaScript file that came as part of the output. So let's go ahead and include xlstool.js, and let's go ahead and view this file now. So if we go back to our little web server here, okay, and because this is the index.html file, the live server, web server just served this up as a default. It didn't even bother showing us the, the browsing of the directory. And if we just take a look at our console, there we go, and we see all of our options there. Now, the very first thing, again, that we want to do is we want to be able to run this. So how do we run this from the web? So the reason we can't run this, or we can't run it on demand, is because we haven't exported any functions. So basically, all the functions that the app does, they're hidden. You can't access them. So basically, what they do is that if you want to be able to access any functions, you have to export them or mark them for export. So, so we're actually going to go back to our Makefile here, and we're going to change just a couple of little things. So first off, what we want to do is we want to add a couple options here. And I'm just going to go ahead and paste this in. So the first thing that we want to set here is this -s extra exported runtime methods and call main. So this is kind of like a built-in function. So most C++ apps have a main function. So let's just find where our main function is. I'm just going to do a quick find here for main, and it's not going to be in any of the tests, and there it is. So that's our main function. So this is, again, what's known as the entry point. And int argc, argv, I'm not going to get too much into these today, but this is basically a standard for C and C++. It expects these to be in here, and this is how it knows what the arguments are. So basically, when you call the app and you're passing in, like the name of the Excel file and any other options, it gets it all in this array. So, I just wanted to show this to you guys just so you understand that this is what it's calling when we say we're calling main. We also want to export it as a function. So this is one of the things. So like you want this to basically wire up this call main wrapper. And then in here, you would list main in addition to any other functions that you want to export. So like, let's say we wanted to export some other function in here. I don't know if there's any others in here, but like this out string. In that case, what we would do is we would basically put the name of that function. But there is like a little bit of a catch, is that you would have to put this underscore in first. And that's basically has to do with how C and C++ they mangle the file names while it's getting compiled. Again, I don't want to get too complicated with that right now because I want to keep this video under an hour. But just just understand that when you do export these things, they have to have this underscore, and that's why when we export main, it's written as underscore main. Okay. And then the last parameter here is called invoke run. This just says whether we want to run the app when it first loads. Now the default is that it does run it, invoke run. So by the default is actually this, invoke run equals 1. But I want it to be 0 because I want to run this thing on demand. So I don't want it to run when the page first loads. So let's go ahead and save that. And we're going to rebuild our app. Let's just do a make clean just to be safe, and we'll do make. Okay. And so now if we go back in here and refresh, now we don't see that output anymore. And that's because we've suppressed that call main. We've said that we don't want to invoke it on the page load, but we do want to invoke it, on demand. So if we take a look at our module object, now we have this nice convenient call main function, and this takes an array of arguments. So I just want to just test it just to see if it runs. I'm going to pass in no, a single, empty string basically, and it says error open file. I'm actually going to pass in just null. I think that's actually better. Yep. So then we see that it does in fact run this app, and I could run this as many times as I want. And that's the beauty of call main, is now I can run this on demand. Now, if I wanted to actually, have this have some usefulness, now obviously I need to give it a file. So we mentioned before, there is no file system, in terms of like accessing my desktop, but what there is a virtual file system, okay? And that's again where you're going to want to just take a look at these objects a little bit and kind of understand what's going on. So module, if we just again take a look at this, you're not going to be using all these functions, but you should understand what some of them are. So heap 8, this is actually, you may not be using it a lot, but it's something to understand. So when you look at this heap U8, this is actually the memory of your app. It's like literally like the RAM basically. So it allocated, 16 million bytes. So it's like 16 megs of memory that this app has. Where this stuff gets useful is, if you need to be able to pull things directly out of memory. If you're there may be cases for that, or if you're doing, some game programming and you want to access, the bits for like a video buffer, that's where this becomes more useful. But as you can see, it's basically just, bytes. So everything is just numbers, and, that's how you're dealing with it. The other object which we're interested in right now is this object called FS, and this is what the virtual file system uses as its interface. So FS has a bunch of different functions on it. So for one, it has this, let's see, I forget what it's called, list directory, read directory. So if we just say read directory, it's basically like doing ls in Linux. So it says, okay, like what are the files that I have? Okay, and that's the files. And if I wanted to, let's say, create a directory, I think it's mkdir. And yeah, let's just, type Excel. So basically what this does is it creates a folder in my virtual file system. So now if I read that out again, now I see that folder, and I can actually, go into that folder and see what's in there. There's nothing in there right now, but you guys get the idea. This is how we're going to be dealing with this, this virtual file system. So, so the first task is you have to get a file onto the virtual file system, and there's two ways of doing that. One is you can preload a function, preload a file, and that's using this. There's another parameter called -- preload file, but I'm actually not going to be using this because I want to show you guys another way that you can do it, without preloading files. Because in the real world, probably what's going to happen is you're not going to have all the files. In a use case like this, maybe the user is going to, first pick a file on their machine, in which case that's not preloaded, that's at runtime. So we need to understand how do we load it in, after the fact to get it into this, this file system. So I'm going to go ahead and go into my script file, and I'm just going to add a little bit of script in here. So the first thing that I'm going to do is I'm going to, at the bottom here, create this window module object. Now, basically what this does is it attaches a couple of, event listeners to certain properties of this module object. The module object is going to be there, and depending on the order in which, you've laid them out in your HTML file, first we're loading our script file, which is our file, and then we're loading the WebAssembly, JavaScript file. So basically what we're doing is we're saying, we're adding on a couple of properties before that file, that WebAssembly file gets loaded. And what's going to happen is when that file loads, it's going to see these events and it's going to wire those up for us. So I basically, a good one to have is on runtime initialized. And that tells you when it's safe to start using the WebAssembly file and its functions. So I basically, I'm going to bind that to a function called the init module. And the next one is for print. So because this tool prints everything basically just to the console, we have to capture that output. And that's what this print event. And there's a lot of other, parameters as well. I'm not going to get into all of them. But this is how you would attach those kinds of events on, different properties of module. So what we're going to do is we're going to attach to init module. So let's go ahead and I'm going to paste in some code that I have here. And so let's just go through what this code is doing. So all this is going to do is it's going to take in this book1.xls file, and it's going to load it using Ajax, right? Because we're on the web, we're not in, a real native app. Everything has to be done, asynchronously using, web technology. So we're basically getting the contents of our Excel file. And yeah, and I'll have all this code, on the GitHub, so you guys can pull it from there. But basically, we just want the bytes, literally the bytes of the file, and that's why we're doing this override MIME type here. And so we're going to get that file, and then we're going to call this fs function, which is create data file. And that's what's going to put it into that virtual file system. So the parameters here are basically where do we want to put it, which folder, the file name, then the content, which has to be a string basically. So that's what we're getting from that, Ajax call, and then just flags for whether we want this to be read and write. So I'm just going to say true for both. So what's going to happen now is that when the page loads, it's going to call init module, which is up here, and it's going to run this code, and it's going to download that, essentially download it in the browser, that file using Ajax, and load it into our file system. So let's see how that works. So now when we refresh, we see that it's printing out the name of that file name, which is a good sign. So let's go ahead now and call book1, and we did not get any errors. We didn't see anything, and the reason we didn't see anything is because we're capturing that print statement. So I'm just going to comment that out for a second, and let's reload this. And there we go. So now we see that it parsed that that Excel file. So that's great. So now what else can we do with this? Let's just go back to our file here, and let's go ahead and capture that print statement. So what I'm going to do is when they click on that button, well, first off, yeah, when they click on the button, it's going to run the app. But I'm just going to want to format this a little bit. So basically, we're capturing that data as we saw in here. It's coming in quotes, and then it's separated by these semicolons. So the good thing about that is we can then parse that, and if we wanted to, we could do something meaningful with it. So that's basically what I'm doing here. Is I'm saying, if I see a line that starts with this this quote, I'm going to first of all remove the quotes. And then I'm going to find that semicolon, which is the delimiter between the cells, and I'm going to replace it with a space dash space just to format a little bit nicer, and then a break after that. And that's what I'm going to set my set the text as. So now, if we go ahead and refresh, let's run the app again, and now we see that we can nicely print it right on the screen. Now, one thing you may have noticed is there is actually a little bug in our little workflow here, is that it printed 3 of the rows, but not the 4th. If we just quickly go back to our spreadsheet here, we'll see that there's a 4th row, Lindsay. So Lindsay did not print. The last one that printed was Maddie. And the reason for this is actually you do get a little bit of a clue here in this warning that it tells you that the stdio streams has not has content in them that was not flushed. Basically, what it's saying is that there's some content left that did not finish printing. It printed internally, but it didn't finish flushing it out of the stream. So basically, what that's saying is that if we have to go back to the code and just modify one thing. So if we go back to our code here, and basically what's happening is that we need to print another carriage return at the end. So one thing to note is that unless it has this \n, the stream is not going to print out. It's not going to flush the stream out of the WebAssembly, and it's basically just stuck in there. So we're just going to modify the code a little bit and put this printf. And that's just a note in general when you're doing anything with Emscripten. If you want to type, let's say printf app finished, unless we put that \n at the end, it's not going to flush out, and we're not going to see that. So by putting this \n here at the end, we're going to make sure that after it's done parsing all of the code here, it actually does get to the output. And just one other thing while I'm here, just to mention, you might have noticed that throughout my code, the IntelliSense is reporting a lot of different errors and so on. And that's really because my include paths are not set up. I'm not going to go too much into that today, just because of the time. I wanted to keep this video at a reasonable amount of time, not to go too over, but just you should know that this is because of the include paths, and there is a settings in VS Code where you can go and you can set all this stuff up. But you basically have to include some header files that are coming from your system. Some are later on going to come from Emscripten. Basically what I'm saying is don't really worry about it. The important thing is that when you actually do build the code, that it actually builds, and in our case it is building, and that's really the important thing. So let's go back to our directory here. Now that we've changed this code, I'm just going to do one more make clean, and let's do make, and let's go ahead and refresh. And actually, I think my web server stopped. Let me just start that up again. There it is. And if we run app, now we do in fact see Lindsay. Okay, guys, well, with that, we're going to wrap things up here. I hope you enjoyed this overview of Emscripten. You should check out the Emscripten website, take a look at the APIs and all the different examples that they have. It's a really great resource, and honestly, you should really just practice it. I mean, that's the best way that you can learn it, is just, go out there, find random GitHub repos and, try porting them. And you're going to run into issues, but if you get through all those issues, you're going to come out with a very good understanding of this technology. So if you like this video, you can leave a like. If there's anything else you'd want me to do a video on, let me know in the comments. And with that, I will catch you guys later. Thanks for watching.